So there are 5 of you that already watched this talk. I remade the slides to be a bit more easy to understand. So that's the only difference since the last time I gave this talk. So Jonathan working on was explaining the new features of Perl6, and I knew a bit of Go, so I want to compare how the new features of Perl6 compares easy of use with Go, and how can we make scheduling of workers in a parallel crawler better, or easier, or more terse in both languages. So for a website, I don't want to do any fetching, any HTTP requests, or any HTML parsing. So I came up with a solution. Let's mock it. And my mock uses an ID instead of an URL. And every page gives 2 other IDs, which are mathematically calculated in a way that's like a binary tree. And no page has a link to the same page as the other page. So this is a promise that simulates fetching a page and giving 2 other links that you can reschedule for other works to start crawling those pages as well. So let's put that in a loop. So we start a single page. In this single page is in the entrance queue. And the input queue goes to the working queue. And then we await for the finish fetching all the work, the initial task that we had in the beginning. So now we have to put the results of the first fetch back into the queue, and we have to iterate through that. So it looks like this. You see that logic that I found here to enqueue the new items and then back into the list was a bit complicated because I was waiting for any of the values. I didn't know which one was finished, so I had to rescan the hash to find which one has finished and then remove it from the queue. And the purpose of this is because I did this code many years back in the C# 3.0, and at the time I had problems with the workers failing due to timeouts or to failed fetches. So I tried to simulate that with some other kinds of, so, no, this is go, sorry. I went too far. So this is my original mock that only returned the links. And I want to simulate some timeouts. And I added these. And I want to simulate some fail fetches. So here you can see a new operator is like, is divisible like that. It's like the opposite logic of model step. And that makes that every 1 in 10 requests, they have a timeout. And I also simulate a fail request here. And even after I added these failures, the scheduling still worked well. To do same with Go, we have to use channels. So here's the mock for the page fetch. And then I added the loop to process all the existing pages to be fetched. And here I added the logic to enqueue again the result of the first fetch. So if I want to limit the number of parallel workers, I just have to add this condition here that will skip out of the loop after I reach the maximum number of workers. So comparing the 2 languages, what can we find? In Perl6, we're using multiple promises. In Go, we're using a single channel. A single channel is forcing you to add an identifier to the response. If you go back here, you can see what I'm talking about. Here, the response receives an ID and the results. Since we had 1 promise per page, we didn't need that for Perl. So when I await with any auth in Perl6, it's the same as waiting on a channel, but Perl6 also adds the keyword all auth. That means you're waiting for all the workers. And then the Tyler came to me with the idea of using the new feature of Perl6 supplies. So what supplies makes? All this work that I had many lines to do, with supplies makes it's much more terse. And I couldn't do that with Go because I could not enqueue new tasks to the same channel I was consuming. And supplies, they have this feature that you can emit and tap from the same supply. And the code was much more simple. So this is working for unlimited number of parallel workers. And if I want to add a limitation of maximum number of parallel workers, I have to add this code here. And it's almost as half of the original code. And that was a lightning talk. So I will put up this slide to some site where you can download and analyze with more calm.